why you get paid the big bucks. Thank you so much. I appreciate it. All right, so then what is the difference between igneous, intrusive, and extrusive rocks? Let's go ahead and do we want some time to share that out? I'll give you a 10-second countdown to turn with the person next to you and talk that out. Ready, set, go. 10, 9, this is going to be hard. 8, 7, 6, 5, 4, 3, 2, 1. Beep, 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 beep. Oh my gosh, Sophie for the win. What do you got?
The intrusive rock is made inside under the Earth's crust, but the extrusive are made on top.
Okay, so we've got intrusive equals inside the earth. Whoops. Come on, little pen. Inside the earth. And we have extrusive equals, you said outside the earth, right? Or outside the crust, outside the earth? Is that right?
Yes.
Thanks. All right. So let's now go ahead and talk about what is happening inside and what is happening outside. I'm going to move down just a little bit so we've got some extra space and that goes up. So what is it that's happening? How are these rocks created? I'm going to give you another 10-second countdown to talk that out with your pair share partners. It's like, what is happening? Okay, ready? 10, 9, oops, 8, 7, 6, 5, 4, 3, 2, 1, and we are done. Beep, 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 beep. What exactly is happening inside or outside? How are igneous rocks created? Katie!
By melting?
Okay, by melting of what?
I think it's melting water.
Okay. So in order to get igneous rock, where do igneous rocks come from? We're not playing. Please, we are not playing. Don't tell me you are playing that in my classroom. Honest to God. Yes. What do you think, Ethan? Cooling of what? All right. So magma is cooling. So magma, my little pen, magma cooling inside the earth equals intrusive. So it's the magma that is cooling, and I'm going to say and hardening, because that is how we get the rock, okay? Hardening. So when magma cools inside the earth, it's intrusive. And if the magma, can we just say exits? Magma exits and cools slash hardens. Exits. Oh, I should have said exits the earth, shouldn't I have? Exits the earth. And cools and hardens, this equals extrusive. Now, because these things, it's made of the same material, but if it is cooling and hardening inside or outside, you are going to get a different result. And so right now what I want to do is I want to take the time to show you a couple of those rocks because, well, I just love rocks. If the magma cools and hardens outside, so the magma has exited the building, it has left the earth, you get these rocks, and I don't know if you can see this or not, but these rocks have like tiny little bubbles in them. You see that? They have tiny little bubbles in them, little holes, and that is showing that the gas that was trapped inside of the magma, as this magma left the Earth's crust, it cooled very quickly, and the pressure was released off of it. And so all of the gas just kind of like released out, and as it cooled, it hardened, showing where all of the little bubbles of the gas escaped. So this is very, anytime you see a rock that looks like this, you know that is rock that has left the Earth's crust, cooled very quickly as those gas bubbles were leaving it. Now, magma that stays inside the Earth's crust and hardens more slowly, you get something that looks like this. This is your typical granite. And so granite has these beautiful little crystals in it. As it is cooling slowly beneath the Earth's surface, these minerals that make up the rock, what they do is they start migrating towards each other and they start growing in size. So in this is pink granite, and you can see pink feldspar crystals. You can see mica, you can see quartz crystal, and you can see that they've all kind of started to come together. If you let it go really, really slowly, you get something that's like granite, but it's on steroids. The crystals can get huge. Has anybody ever heard of topaz or citrine? Those are beautiful crystals that we find in this, which is called pegmatite. So you see the colors of this, which is granite. This has got the same minerals in it, except the crystals, the individual crystals have gotten huge. And you get big sections of black mica, and you get big sections of beautiful quartz, and huge sections of pegmatite, which are these beautiful pink. Here's a really nice crystal. I don't know if you can see it on screen, but it's all this beautiful pink pegmatite. Okay, that's the small little tiny pink crystals in here. And so if you find an outcropping of pegmatite, look for topaz and things like citrine. You can find gemstones in this. All right, that's what I want to talk about there. What I want to do now for the remainder of our class time is I want to do let's hang out in the back lab area and just look at some different rocks. I want you to be able to play with some rocks. And then after we do that for about 10 or 15 minutes, I'm going to ask you to play like a guessing game. Didn't we start this on Friday?
Yes, we did.
But we didn't finish it, did we? So we're going to go ahead and go through it again, see where we're at. I took away the answer keys from the boxes. And then afterwards, I want to give you the remainder of the time for a catch-up and pickles day, which means I want you to catch up on past work that you have outstanding. For example, vocab. That was worth 5 points in my class. And so I want to make sure that you get the vocab done so that you can show me that so that you can be passing my class, right? Get as high a grade as you can. And then the remainder of the time, you can catch up on work from other classes, because I know that I think today you've got science exams, which you don't have one for me, and then math exams are today too. Is that correct? So you can go ahead and take some time to study for your exams or do anything else that you have outstanding for another class. Absolutely no phones, but work on things like missing quizzes, missing lab assignments, and your vocabulary. So what I want you to do is, do you remember the groups that you were in Friday?
Yes, I did.
Could you please go back to those groups, and then I'm going to show you the rocks that I want you to get out. So we're going to examine some rocks, and these are what I want you to open up the box, and I want you to get out these rocks, please, at your station. So on your marks, get set, go. Okay, how about we find out who you have? Yeah, please be off your phones. Thank you very much for being off your phones. Let's go ahead and put you, can I put you at group 2 with Key and, oh, it looks like we already have enough people at group 2. Let's see if we're missing what we're missing. Just you and who? Great. Can you go with Alicia? Okay, so then how about we put you, Okay, so then how about we put you and Ryan together? Alicia, where are you going, kiddo? How about we either you two either go to group 6. Do you want to just the two of you work together? Are you going over there? Okay, then how about the 3 of you go over there? Get out these rocks, please. Please get out these rocks. Let's see how fast you can get these rocks out, please. Great, then close the cover. Once you get these rocks out, please close the cover. You should have 11 rocks, darlings. 11 rocks. 11 total. 22, and then it's 25, 26, and then it's going to be 32, 33, 34, 35, 36, 37, 38, and 40. Thanks, Sophie. As she's chewing gum. Hippopotamus crab. All right, so at your station, you should have 11 rocks. Do we have these 11 rocks out, darlings? Great. The next thing that I need you to do for me, please, is I need you to separate the rocks into what we think are 3 groups. Use the tags that I have at your stations and separate them into igneous, metamorphic, or sedimentary. You're going to have a 10-second countdown on your marks. Get set, go. 10, 9, 8, 7. You don't have all the rocks yet? Then when I said, hey, are we ready to go? Why didn't you say no? You might have to work together as a partner, which means Ryan and you are going to have to look for these numbers. It can't be one person doing the work because then you'll just find out you're not ready to move on to the next stage. 10, 9, 8, 7. I don't have answers for you in your packet, buddy. Just look at them and say, hey, I think this would be igneous. Hey, I think this would be sedimentary. Okay, let's pause for a second, if you could, for me. At this time, everybody should have 11 rocks out. If your 11 rocks are out, please close the lid and don't touch the other rocks. I need the other rocks to be closed. Could you please close the lid on the box?
Can you see the numbers of the rocks again?
These are the numbers you should have, sweeties. Ryan, honey, you're taking all kinds of rocks out that you shouldn't. You should have these rocks out. Look at each rock has a number on it. You should only have these rocks out. Let's just look at these rocks and then please put the lid on the rocks. Are we good? Okay. Now, can we please separate these rocks into 3 groups? You've got 3 labels at your station: igneous, metamorphic, and sedimentary. Igneous rocks are rocks that were cooled from magma. Metamorphic are rocks that were changed due to heat and pressure. And sedimentary rocks are rocks that were formed due to compaction or cementation. And we're going to have to check out our cemented rock in just a minute that we created, but not right now. So I'm going to get my phone and I'm going to put 30 seconds on the clock. Let's go ahead and do a 30 seconds. And in 30 seconds, I'm going to show you the right answers for what these rocks are. So go ahead and you and your partners decide within 30 seconds how to categorize that. Ready, set, go. Please don't do that, Aiden, because if you drop it, it'll break and it would make me very sad.
I'm sorry.
I appreciate that. You have 11 seconds. Put them in groups. 3, 2, 1. All right. Let's go ahead and play and see if you were right or if you were wrong. So I'm going to go ahead and move these down. Below are the groupings. Let's see if you were correct or not. So this first group, 22, 25, and 26 should be together. What do you think these are? These are sedimentary rocks. Good job. 32, 33, 34, and 35 are together. What do you think these rocks are? What do you think? These are igneous rocks, which means the rest of them are metamorphic. All right. Are you missing one? Were you missing one? So now that we have them in the different groups, let's play around with these groups. Okay. Task 3, just look at the igneous. Can you just put the igneous in an area and then just kind of move the other ones away? I want you to look at just 32, 33, 34, and 35. Can you try to imagine which ones of these are intrusive and which ones are extrusive rocks? I will give you 36 seconds to talk with your pair share partners. If you had to separate those igneous rocks into intrusive, meaning it cooled inside the earth, or extrusive, which means it cooled outside of the earth. Ready, set, go. Igneous rocks. Intrusive or extrusive? Aiden, please don't be on your phone. Yep. Thank you.
No, that was intrusive.
You should have 2 piles now, intrusive or extrusive. All right, let's go ahead and see how we did on that as far as the intrusive or the extrusive. So as far as the intrusive rocks, all of our intrusive rocks were numbers 34. Did anybody think an intrusive was 34? Did everyone get that right? I'm hearing nothing from you. Yes, all right. And 35. Those were both intrusive rocks. Extrusive rocks that cooled outside of the earth in order to be created were 32 and 33. How'd we do? Good? Fabulous. Let's go ahead and move down to just the sedimentary rocks then and the metamorphic. So just move the igneous rocks over, and now let's look at these. Could you please get 22, 25, and 26, which is your sedimentary, and your metamorphic rocks, which are numbers 36, 37, 38, and 40. Remember, metamorphic rocks are rocks that have been changed from another rock. So look at those 3 sedimentary rocks. Okay, so I want you to imagine this. I'll set it up for you. Imagine 22. Which metamorphic rock did that change into? 25. Which metamorphic rock did that change into? And 26. Which metamorphic rock did that change into? And can someone remind me, what has to happen to these sedimentary rocks in order for them to be metamorphic? Nope, that's how you make sedimentary rock. Good try. Yeah, that's right. We have to have extreme heat and pressure. So you all figure out which of these rocks were turned into. Extreme heat and pressure had to happen to these rocks in order for them to turn into which rocks? $20 more seconds. Five, 4, 3, 2, 1, and done. Let's go ahead and do 22. What do we think 22 turned into? Okay, 22 turned into 38. How many of you got that one right? Woo! 25, do you want to guess this one? 40, that's right. 25 turns into 40. And then 26, which is a sedimentary rock, turns into 36. That's right. So we have, y'all right? So we have just one, we have one left out. So let's go ahead and look at that. Let's go ahead and look, thank you. Let's go ahead and look at that last metamorphic rock that we weren't able to match up and get the igneous rocks out. Look at the igneous rocks, which are 32, 33, 34, and 35. And the remaining metamorphic rock. Which of the igneous rocks do you think this metamorphic rock started out from? So which of these, 32, 33, 34, 35, turned into 37? I'll give you another 20 seconds on that one to see if you can figure that out. Ready, set, go. So again, we are looking for something like this. What, dear?
I got all the rocks, all three of them, and then like all of them. So these three.
Good job. Maybe you'll be a geologist.
No.
Hey, you could have worse jobs. And you get to spend all day like outside working. All right, so what do we think? Which one of these rocks, 32, 33, 34, 35, turns into 37? Any ideas? Aiden?
34.
34. Let's go ahead and see. I didn't have my thing in front of me. Actually, it's not 34. It's 35. 35 turns into 37 if you add heat and pressure to it. All right, now let's go ahead and see if you can name them. Let's see if you can identify them. Let me move my face out of the way and make this a little bigger. I know that you do not have, you don't have experience in rocks, so I'm going to go ahead and give you I'm going to give you a word bank for this. So one of these rocks in sedimentary is sandstone. One of these rocks is called shale, and one of these rocks is called limestone. So with your partners, let's see if you can figure out which of these rocks is sandstone, shale, and limestone. On your mark, get set, go. Are you all letting Clara play, or is just Clara not wanting to play?
It's just her just.
All right, let's see how we're doing our time. 3, 2, 1, and we are done. Okay, 22, what do we think it is? It's not limestone, actually. 22, my darlings, is, oh, it is limestone. I'm sorry. It is. Yes, limestone. Good job. 22 is limestone. Nice. There's lots of limestone all over where we live. So limestone is out. Bloop. 25, what do we think?
Sandstone.
It is. 25 is sandstone.
Boom.
And then the last one is shale. Shale, if you heat it up and put it under lots of pressure, that becomes slate. That's what the old chalkboards were made of. All right, let's go ahead and look at the igneous. Get your igneous rocks out, 32, 33, 34, and 35. And here is your word bank for that. One of them is going to be granite. One of them is going to be called gabbro. One of them is going to be called basalt. That is the crust at the bottom of the ocean. And then one of them is going to be pumice. All right, you have 20 seconds. Your time starts now. Am I blocking you? Can you see it?
No, this one I do.
Our time is up. Let's see how we did on this part of Guess That Rock. So 32, what do we think it is? Let's pump up the amps in here. 32, what do we think? 32 is pumice. Good job. How did you guess? What gave it away? What gave it away? What were the clues? Okay, fabulous. 33, what do you think? 33 is basalt. This is what's at the bottom of the ocean. How many of you got that one right? All right. 34, what do we think? This one is gabbro. And then the last one is granite. That one is probably what you are most familiar with in that grouping. You're probably most familiar with limestone in the first grouping, and then there's this one. All right, last but not least, oops, too far, Miss McGrain. Let's go ahead and look at our metamorphic rock. And so in here, these are your choices. You have a rock called gneiss. The G is silent.
That's very nice.
It is. So we've got gneiss. Then you've got something called slate. That is what shale turns into. You've got marble. I'm thinking maybe this is going to be what you're most familiar with here. And then you've got a very hard rock called quartzite. All right, 20 seconds. Let's see how you do. On your marks, get set, go. Who in here had a rock collection as a child? Me
I have a
too.
quartz collection.
My kids both had rock collections too.
I have
Well,
this big,
no, thank you for not swearing.
I have this big quartz.
I think that's great. Quartz is like a mineral kind of thing. All right, let's go ahead and do this. 36, what do we think?
No food at the table.
36, what do we think? You're killing me.
You're killing me.
Slate, that's right. It is. Nice try. Way to put yourself out there. I appreciate it. It is slate. How many of you got slate right? Whoop, whoop. Okay, the next one is such a nice rock. This one, does it look banded kind of? Does it look like it's got some stripes in it that maybe have been smushed and flattened?
Yes.
That's nice. Another one that is kind of like a metamorphic rock is schist. It's nice and schist. You can have a nice day or a schisty day. Okay, so then the next one, 38, is marble. Last one is that very hard rock that's called quartzite. Oops, sorry, spelled it wrong there. Quartzite. Nice job. How'd you do with the metamorphic rock? Did anybody get all the metamorphics right?
No.
I tell you what, in one of my classes on Friday, we did this, and my student was like, yes, I got that one right. Yes, it's this. I'm like, oh my gosh, you should be a geologist. Go out there and study them. All right, my dears, so here's what we're going to do for the remainder of the class period. What I need you to do is please put the rocks back. You should have 11 rocks that go back in 11 different boxes. In that one box, or those little holes. Is that a donut? Looks amazing. But you shouldn't be eating back at the lab table, sweetheart. There's a big sign right there. Look at the sign on the wall. Once you have the rocks back, could you please, for the remainder of your class period, I'll wait till everyone's ready. It's not fair for me to give you instructions when you're not listening. While we're in here, does anybody have any other questions about any of the other rocks that you want answered? Do you have any other rocks that you're like, what's this one? What's that one? Any other rocks that you're interested in? Any other rocks that you're interested in knowing about? Was anyone ever able to find which one was sulfur?
I want to know what this one is. Is it the yellow one?
Sulfur. Smell it. It's sulfur. Yep. Did anybody find fool's gold, which is also known as pyrite? That's fool's gold. That's right. They call it fool's gold because it used to trick people. They thought it was gold, but it's pyrite. It's like an iron. If you have a magnet, it'll attract that because it's got lots of iron in it. All right. Thank you. Come and have a seat, my dears. What we are going to do now is it's a catch-up and pickles day. You are going to catch up on work or pick something else to do. Absolutely, though, no phones. Absolutely no phones. The first thing I want everybody in here to look at is your vocab. If you need to get a book out or you need to get your computer and define those vocabulary words, there's 11 of them. Get it done so that we can see that you have to get that done. So I want to get those points. I want you to get your vocab done. Get your vocab done, and then we'll talk about that. What's up, darling?
Good.
So for those of you at home, it's Ketchup and Pickles Day. I'll see you later, and peace out.
Look, Chromebook cards right